Good morning students. Let me introduce myself. I am Dr. C. Thamarai Chelvi, Associate Professor of Chemistry, the Standard Fireworks Rajaratnam College for Women, Sivakasi. In this module, we have learned about Mossbauer spectroscopy. First we know about what is Mossbauer spectroscopy, and then next we know the principle of Mossbauer spectroscopy, and finally which source is used to get the Mossbauer spectroscopy. First, introduction. The Mossbauer spectroscopy is discovered by Rudolf Mossbauer in the year 1958. This Mossbauer spectroscopy is more aptly described by its alternative name, nuclear gamma resonance spectroscopy. This spectroscopy is also called as nuclear version of electronic spectroscopy. This is sometimes may be abbreviated as NGR. This spectroscopy can be considered as the nuclear version of electronic spectroscopy. It can be carried out on a variety of heavy nuclei and different sources required for each one. As the name suggests, the nucleus is probed using gamma rays as an exciting radiation. A gamma absorption spectrum is measured. Rudolf Mossbauer, born on January 31st, 1929 in Munich, Germany, discovered the Mossbauer effect. He won the Nobel Prize in Physics in the year 1961. First we know about what is the principle of Mossbauer spectroscopy. Here the gamma ray is emitted from the source. That emitted gamma ray is absorbed by the sample. The absorption of gamma ray is measured using the Mossbauer spectrum. Here, if the emitting and absorbing nuclei is a free one, the recoil energy is increased. To reduce, what is meant by recoil energy? Here the recoil energy is nothing but of, just as a gun recoil when bullet is fired. Here the conservation of momentum requires a free nucleus to recoil during emission or absorption of gamma rays. It means nuclear resonance is unobservable with free nuclei because energy shift is too large to have a significant overlap of emission and absorption spectra. So to reduce the recoil energy, increase the mass of the sample. For this reason, the Mossbauer spectra is always obtained on a solid state. So the sample is placed on the solid support. Here, if the sample is placed on the solid support, the recoil energy is minimized, and also we get the clear Mossbauer spectrum. This is the principle of Mossbauer spectroscopy. And the next will use what are the conditions needed if the substances act as a source in Mossbauer spectrum. If you want to analyze the ion sample using Mossbauer spectrum, the radioactive 57 cobalt is used as a source. It slowly decays to give excited state ion 57. This nuclei decays quickly to the ground state ion 57 with the emission of gamma ray. Here the gamma ray is emitted from the source, that is absorbed by the sample. The conditions have to be satisfied. First, the energy of transition have to be large but not larger than the lattice vibration, that is nearly 10 to 150 electron volt. For example, if we take a excited ion 57, it releases 14.4 electron volt of energy. That gamma ray emission is enough to absorb the sample. The next, the substantial proportion of excited state nuclei should be there. In the third condition, the lifetime of excited state should be large to have precise energy of transition, but low enough to have an intense line in spectrum. That is, the lifetime of the excited state nuclei is 1 to 100 nanoseconds. Then fourth condition, the excited state of emitter should have long life precursor. If you want to analyze the ion sample, you have chose 57 cobalt as a precursor. And then fifth one, ground state isotopes should be stable. Finally, the cross section of absorption should be always high. Example, 57 cobalt is a source of gamma ray emission to analyze the ion sample. Thank you for watching.